So in this video, we're going to do an example problem for the given state of stress in the XY coordinate system. We're going to try to find the principal stresses, the maximum shear stress, and the state of stress after 45 degrees counterclockwise rotation. So, um, so we're just going to follow the Mohr circle procedure that was introduced in the last video. So the first thing we're going to do is we're going to find the center of the circle, right? Of our Mohr circle. So the center is going to be equal to sigma x plus sigma y divided by 2, and the y coordinate is going to be equal to 0. Okay, so sigma x in this case is equal to 3, sigma y is equal to 9, and then we're going to divide that by 2. So we're going to get that's going to be equal to 6. So our coordinate is going to be equal to 6 and 0. All right, so if we look at our coordinate system that we have, all right, 6, 0 on the coordinate system is going to be equal to 1, 2, 3, 4, 5, 6 here. So this is the center of our circle. All right, so that's the first step. Plot the center of the circle. The second step is to calculate the radius. All right, so the radius is going to be equal to the square root of sigma x minus sigma y divided by 2. All right, plus tau xy squared. All right, based off of our initial values, we're going to get the square root of 3 minus 9 divided by 2 squared plus tau xy, which is equal to minus 4 squared. So what we end up getting here for our radius is going to be equal to minus 6 divided by 2, which is equal to minus 3 squared, which is going to be equal to 9 plus 16, which is equal to square root of 25, which is going to be equal to 5. Okay, so we're just going to count 1, 2, 3, 4, 5, and that's going to be the location of our radius here. Okay, and from that radius, if you had a compass or you have a computer software, you could draw out your the radius of your circle. All right. So step 3 is to locate your principal stresses. So principal stress 1 and principal stress 2. All right. So these are going to occur. These occur at the x-intercepts. You could also think of this as when y or when tau is equal to 0. This is where this would occur. So our maximum principal stress based off of this is going to be sigma p1, which occurs at 11 kpsi, and our minimum principal stress is going to be sigma p2, which is going to be equal to 1 kpsi. All right. So we just follow the locations of the intercepts. Okay. You could also say that sigma p is equal to the average stress, which is sigma x plus sigma y over 2, which is the location of our centroid, plus or minus the radius of our Mohr circle. Okay? So, alright, so that was the first, we were asked to determine the principal stresses, so we were able to do that. The next thing it asks for is where is our maximum shear stress. So our maximum shear stress is going to occur at this location here, based off of our Mohr circle. So that is going to be at it's at the location. It's going to be at the average stress, sigma x plus sigma y over 2, and then the value of it is going to be equal to the radius of our tau. All right, so this is our stress and this is our shear at that point. So tau max is just going to be equal to the radius of our Mohr circle. All right, so in our procedure, the next thing we can do is we can plot the location of the current stress at the point. So we can go to the current state of stress. We can plot point P. All right, so plot point P, which is at sigma x and tau xy. And we can plot point Q, which should be 180 degrees away from it. So that should be equal to sigma y and minus tau xy. So let's draw those points. So point P, based off of our stress state, would be at 3 minus 4. So that's going to be at so this is our origin point, 1, 2, 3, and then minus 4, remember, is going to be along the positive, along the traditionally like positive y-axis. So this is going to be 1, 2, 3, 4. This is going to be point P here. And then point Q would be at 180 degrees apart. So you could draw, if you draw a line straight through the the origin point here, you should arrive at the other point Q here. So at point Q is going to be at 9 and then positive minus negative 4, which is the same thing as being 9, 4. Right? So if we look at their x-axis, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we can go up positive 4, 1, 2, 3, 4. Okay, so this will be our point Q. All right. So the last thing we're asked to find is we're asked to find what would be the state of stress after a 45 degrees clockwise rotation. So if we go from our current state of stress and we rotate it 45 degrees, what would be our new state of stress? This is the same thing as rotating. This is in the xy plane. We can say theta is equal to 45 degrees in the because we are in the Mohr circle space, we have to multiply that 45 degree rotation by 2, so we need to rotate it 90 degrees here. All right, so what we can do is we can rotate this state of stress by 90 degrees on the Mohr circle, and we can redraw it. So if we do that, we end up getting our P prime and our Q prime. Okay, so we can just draw it, approximate 90 degrees, and redraw it all here. All right, and we should end up getting, I think, let me redraw it here, and we would get our new state of stress P prime and Q prime. So from P prime, right, we know that that's going to be our sigma x and tau xy prime. And then from Q prime, we could get sigma y prime and minus tau x prime y prime. So from this, our new state of stress from the graph looks like it's going to be equal to 10 k psi after along the x direction. It's going to be equal to 2 k psi along the y direction, or the y prime direction, I should say. And then our tau xy is going to be equal to negative 3 to equal to negative 3 k psi. Okay, so based off of these points here. All right, so the last thing that you can do on the Mohr circle, which I forgot to mention for the principal stresses, is you can measure this angle from point P to from point P to the first principal stress axis here. This angle here, which I'm gonna highlight here, which is gonna be called sigma p1. Or sorry, that should be not sigma p1. That should be theta theta 1x. All right, and then you could also calculate uh, this angle here. So this is equal to 2 theta 1x, and then this other angle, which should be equal to 2 theta 1 y. So those are the angles between the x-axis and the first principal stress axis and the y-axis and the first principal stress axis. So you just divide those measured values by 2, and then you could calculate the principal stress angles. Okay. So all right. So that's it. So that's it from the Mohr circle. You can calculate basically all the information you can calculate from um, the original stress shear, like principal stress equations and stress transformation equations, and it's all that information is available for you graphically for you just to read off and and write down. So it's a great way to check your work to make sure the values that you're getting are correct.